30-1, so we're going to continue on with this unit by starting the next chapter. We're going to do function operations. So in this chapter, we're going to be taking a couple of functions. We're going to add or subtract them, multiply and divide them, put one function to another. We call that a composition. We're going to analyze the resulting graph. What's the new domain? What's the new range? Are there any differences? Any problems that we arise when we put functions into functions? So let's get started here. So hopefully you're able to print this section off here. We're having some difficulties with the printer. Hopefully, maybe by now we've been able to print them off. Who knows? But the first few operations that we're going to be doing today for this lesson is going to be just the simple ones. We're going to take the sum, the difference, and the product, and the quotient rules of doing function operations. And so this little slide here, this little box here, there may or not be a box by the time I print this off, is just telling us different ways to represent the same thing. So if you see this idea where you see f of x plus g of x here, that's just saying I'm going to add these two together. But if you see it written this way, see f plus g of x, the way it's kind of written here, they just mean the same thing. It's just a different way of representing the same thing. Now, the very key is this product here is a dot, it's a solid dot, right? You're going to see later on when we talk about composition, where you're going to see a hollow dot there instead. So you might see something that looks like this. If you see a hollow dot, that means I'm going to put a function into another function. So it's going to look like that. So this is getting put inside f of x, right? If you see a solid dot like this one, it just means you're going to multiply those two together. Okay. And then we're going to do some divisions. You notice that there's a restriction here. If g of x happens to be 0, then we have a divide by 0 error. So we do have some new restrictions on divisions. Okay, so let's look at, for example, number 1 here. What does this mean? So here's f of x plus g of x. So they give us the two equations here. So f of x, there's an f of x there. This is g of x. Here's g of x here. So it's literally just saying, well, let's label this h of x so we have a new name for it. That h of x is just going to be the addition of these two graphs. So this graph plus this graph. There. And then just add them together. So we've got x squared plus 3x minus 2. So I get this brand new graph here. Okay. Then it asks you for the resulting domain and range of this. Okay, so you look at this before we started. Usually when you do the adding and subtracting one, whatever the domain and range of those graphs were is the new domain and range for this one as well. But it's just a regular quadratic. So it's just XER. And now we just have to look about where's the min point of this graph here. It's a quadratic. Can't really see where the min point is. So maybe I'm going to change it into vertex form. You could just graph it, put it in a graphing calculator, just graph and see what it looks like. But if I change it into vertex form, it could look like this. So I'm going to take that 3 divided by 2. So I get 3 halves here. 3 halves squared. I'm going to get my calculator out. 3 halves squared. And then I'm going to plus, and then I'm going to minus that. So I'm going to minus that over to the side over here. So it looks like I got 4.25. We could just verify that by using our calculator here. It's opening upwards, because you can see that's opening upwards. So it's got to be greater than or equal to negative or 4.25 YER. Okay, it looks pretty good. Give it a little bit of time for my calculator to warm up here. I think I hit the button right. There you go. So while we're doing that, let's just look at the next equation here. Okay, so in the next equation, we're going to subtract these two. Now, subtraction is very important, the order of the subtraction. So let's just call this h of x as well. So h of x is equal to f of x, sorry, minus g of x. I'm going to write that out. Now we're going to run into this typical problem where you have a minus minus situation. So a minus and negative 4 turns to a positive 4. So we got negative x squared plus 3x, and then I get plus 6. Okay, we get another little quadratic here. So x squared, or xer is my range. And we're going to find out what our, or sorry, domain. We're going to find out what our range is on our graph. I'm going to show you a little trick on the graphing calculator too, where actually might be quite useful to help you figure out what do these new domain, what do these graphs look like, what's the new domain and range. So the trick is that we're going to graph both of the graphs separately, and then we're going to add them together in the next line down. Okay, so our two graphs are 3x plus 2 and x squared minus 4. So I'm not going to graph the final graph. I'm going to graph the two original graphs. So I got 3x plus 2, and then I got x squared minus 4. I think those are my two graphs. Let's see, 3x plus 2, x squared minus 4. Okay, sweet. Okay, I don't want to see these graphs, so what I'm going to do is I'm just going to turn those off. All right, so they don't plot. You can, if you want to plot them, you can, but I'm just worried about what these graphs look like when we add them or subtract them. So f of x is the first one here. So what I'm going to do is I'm going to go alpha, and I think it's alpha trace, yeah. If you have one of these new calculators, alpha trace, and you can load these up. If they're not there, what you can do is you can go over to hit vars. So you're going to hit vars over here. Go over to y vars, hit function, and there's y1, y2 here. So what I'm going to do is I'm going to take y1, because that's f of x, I'm going to add y2. So that's the graph I want to see. Maybe I'll zoom in to a standard here. This is my typical graph. I want to find out what the min point of that is for my range here. So I'm going to go min. I can hazard a guess. It's got to be between -2 and -1. So I'm going to punch those two numbers. You can see the two lines are created here. My min point's somewhere in between. So -4.25, exactly what we had before when we completed the square. So we were right on that. All right. So we can actually now go back to our graphing calculator and just go to the y is equal to and just change this to a minus. So f of x minus g of x. Hit graph. Here's my new graph. I can find out what my max point is there. So I'm going to go second trace. Max. I know it's a max from before because the leading coefficient is a negative, but 8.25. So if you wanted to complete the square, you can. In this case, I don't need to. I just know it has to be less than or equal to -8. Oh, positive 8.25. YR. Okay. Now, the reason I don't plot the new graph after I simplify is because sometimes when you simplify, you lose your non-permissible values. So you want to keep your equation as complex as possible before you graph it to see what the domain and range should be. You do want the simplified equation, but then you have to put in those restrictions that you lose, those non-permissible values or any other things that you have to worry about, such as square roots of negatives and logs of negative numbers. So here we got h of x. We're going to multiply these two together. So we got 3x plus 2 times x squared minus 4. So I'm multiplying these. There's a solid dot there. So I'm going to use the whole distributive property. So I'm going to go 3x times x squared, 3x times -4, and then -2, or 2 times both those as well. So I'm going to have 3x cubed minus 12x with that piece. Seems right? Yeah, seems right. Just do some quick little mental math there. You get 2x squared minus 8 for that part. So I simplify this down. 3x plus 2x squared minus 12x. You see I'm just putting a descending order of degrees, so 3, 2, 1, 0. So this is my new equation here. So I plot this on my calculator, but I'm not going to plot that. I'm actually just going to go to the y is equal to. I'm going to go down here, just times that, change that minus sign to a times sign, graph that. It should end up being cubic. Yeah, it looks like a pretty cubic graph. Doesn't look like there's any holes or anything. Usually when you multiply, add, or divide, you don't introduce any holes. So whatever you had before is our domain and range. So this is a pretty cubic graph here. So XER and YER. Leading coefficient is positive, it's cubic, so we're going to have this shape. So I'm going to go up forever, down forever, and side to side forever. Okay, so now what I'm going to do is I'm going to divide. So this is where we're going to introduce some new problems to our graph. So let's say our graph here, h of x. So let's call that h of x there. I'm going to take f of x, which is our 3x plus 2, and I'm going to divide it by my g of x, which is my x squared minus 4. Now, what I know about this is that when I divide by something, I can't divide by 0. So what I'm going to do with the bottom is I'm going to factor it out first. Remember that from rational expressions. You always want to be factored. And I'm going to realize, oh, my x cannot be negative 2 and positive 2. Now, you might end up in the point where you divide out those factors and you get a non-permissible value. But in this case, I just get 2 vertical asymptotes. Let's see what that looks like when we do this. So we go over here. You take those 2 equations, f of x divided by g of x. You graph. Yeah, we got our 2 vertical asymptotes. You can kind of see that. One at negative 2 and one at positive 2. Got a graph going that way. You got a horizontal asymptote on either side here, but you notice that this line does cross through the horizontal asymptote. So that's not going to be part of my range. So what I have for my domain is x cannot be 2 and negative 2, XER, and y, YER. So there is a horizontal asymptote, but because that middle part kind of crosses through, you can see from the graph, even though I have a horizontal asymptote with y is equal to 0, we don't include that down here. Yeah. So those are the 2 simple ones. Now, we can add more complexity to these kind of questions by adding radicals or logs or exponentials to these, especially logs and radicals, because there's more restrictions. What I know is I cannot take the square root of negative numbers. This is what should say is not equal to, but is equal to an unreal solution. So imaginary numbers and stuff.